for the first time in public, our new product. It's a JavaScript debugging robot. We're a young startup. We're based out of Switzerland, and we came all the way to here to present this. Just before I start, a bit of background. This is Switzerland, right? It's lost in the middle of Europe. It's about as big as Florida, maybe even smaller. I don't know. And there's usually a confusion between Sweden and Switzerland. So we're from Switzerland. Sweden, this is IKEA. Switzerland, it's Swiss cheese, right? So I'm out Blockbuster. So we love robots, and I guess everybody loves robots because they do lots of useful things for you. For instance, you can buy a robot to mow your lawn if you have a garden. You can buy robots to clean your floor or scare your pets, depending on what you want to do. Or you can even have these really cool flying quadcopters, right? So all these robots, they're really nice because they're going to do all the things that you don't really want to do yourself. But if there is one thing that we want to do is programming, right? If we all love programming, especially in JavaScript, otherwise we would be on the beach or somewhere else. I don't have to teach you how great JavaScript is. You can do great server-side application with Node.js or program robots. Now there are these cool operating system for mobile, Firefox OS or Chrome OS for with their nice Chromebook. So there are really a lot of things that you can do with JavaScript. What we really don't like is that bugs. It's a fact of life. If you write code, you're gonna have some of these at some point. That's not good. But this cannot be helped, right? You're just gonna have to handle them. Let me just give you a very simple example. This is taken from a website. It's a simple form to sign up to the mailing list, and this is the code that is behind it. So it's JavaScript using jQuery, and the only thing that it does, it handles the submit event, and then it uses a regular expression to parse the email address to make sure it is syntactically valid, and if it is, then it submits the form. So how can, what can possibly go wrong here, right? It's only, less than 20 lines of code, right? Well, first you could, make a mistake with, the CSS selector and not get the right value or not get any value at all for the email address. Then you could make a mistake, in the regular expression, that never happens. But, and then if it does happen, well, this if statement over here is not gonna, do the right thing. So you might actually submit something invalid to the server, or prevent somebody from submitting something valid. So that's not good. And then even if all this code is correct, you're going to post a request to a server, and then the server is going to do God knows what, work with a database, with some other services, and might blow up. So you might have a problem there too. And then of course there are a bunch of function calls, to other pieces of code that might also have problems. So it's a very simple example. There are about 13 lines of useful code in there. There are about 6 lines where you could possibly have a problem someday. And that's not even counting problems with libraries. So that example was using jQuery. Well, I guess jQuery is pretty stable, but you could upgrade to a newer version of jQuery and all of a sudden have some unexpected behavior. So something will break sooner or later. So what can you do to make things better? Well, you could use a strongly typed language, maybe. But this example was syntactically valid. There was no type problems, and still, there were lots of places where you could have issues. You could use better compilers, or compilers to begin with. But again, that example there, it wouldn't help, right? Because the problem, with CSS selectors, that kind of stuff, there is nothing a compiler can do. Now you could try to implement some very fancy static analysis tool. That would certainly be useful, but the problem with static analysis is it has to speculate about what your input is going to look like. So in general, it's going to be difficult to prove or disprove that something's going to work or not. So in the end, you're left with testing. That's the only solution if you really want to make sure that your thing is going to work over time and not break. So speaking a little bit about testing techniques, right? So what are the techniques out there? Well, obviously you can test your code manually. When it's just mailing list sign up, well, that's not too much work. You can do it yourself. But in general, you have better things to do than keep on clicking and typing stuff to see if it works. Then you can write unit tests, which is very useful, and you should definitely do that. But it's not as easy. For instance, if you have a server or if you have some fancy libraries, you're going to have to mock stuff, and it's not necessarily easy to test the entire stack. And then finally, you can write integration tests using Selenium or Phantom.js. And that's basically the only solution if you want to test the entire stack. And so you would write something like that, just wrote a few lines. It's relatively easy. But the problem is basically it forces you to write more codes, right? So you're testing code and you have to write more code. That's basically the testing paradox that we have nowadays, right? So the additional code that you write in order to test your feature has to be debugged as well and has to be maintained over time as well. And so at Bugbuster, our vision is to try to solve this problem using a robot. So sorry to disappoint you, it's not a physical robot, it's a software robot. It's just a piece of software. But it basically does the same thing as your vacuum cleaner, right? It goes around your code and tries to find the dirty places. That's basically the so what it does is it explores your HTML and JavaScript by itself. So it basically uses the application. And while it does that, it detects bugs. On top of it, we have a very expressive timing insensitive API that enables you to control the robot a little bit better. And the goal with this is to test a lot more with less code. So speaking about automatic exploration of code, how does it work? So it's fairly simple to understand. First, Bugbuster is going to load your application. Then it's going to supply input. So it's going to trigger an event somewhere by typing a value or clicking on a button. Then it's going to analyze the event handler code, basically as it is executing. And it's going to unfold the control flow graph. So basically, if you have if statements and stuff like that in your event handler, it's going to unfold that. And it's going to figure out that there are various sides of these if statements. And then it's going to try to generate new input in order to cover the different sides of these if statements. And if you can do that, then it will go back to step 2 in order to supply additional inputs, trigger again the same event handler, and cover the other parts of the code. So if I continue with my sign-up example, the first thing it's going to do is, well, it will figure out that there is one input field, so it's going to type a value in there, an A. That will not trigger any event, so it will just carry on and do something else. So what it will do is it will click on the sign-up button. That will trigger the event handler and cover the first part of this if statement over here. What this if statement does is, it runs this regular expression to test the validity of the input. The input here is A. It's not a valid email address. It doesn't match the regular expression, so it stops there. So what it will do, it will actually resolve this regular expression to figure out another piece of input that could be typed into this text field instead. And so if it successfully does that, then it can type something else in the text field. So in this example, it will type something that looks random, but it's actually not random at all. It really matches the regular expression. And so it types it again and clicks again on the sign up button, and now it has covered the entire code for this event handler. So that enables you to get great code coverage and to find if there is an exception or if there is an assertion or something like that that fires in this piece of code, then it will catch it and report it. What is this good for? Several things. First, you can use that for exploratory testing. So this is, for instance, you have an application. It may be new, or maybe you don't know it very well. You can, launch a robot on it, let it do, different things, see what happens, and get an assessment of the code quality. You can also use this to do more systematic testing. So one problem when people are writing test cases is that they have sort of a conception of how the code works. So they're going to write the test cases by following this sort of mental model that they have. And so they may miss, corner cases. By analyzing the source code, we're actually able to try and cover as much of the code as possible, including the corner cases. So you can use that to systematically test your code. It's also very useful for testing large code base. Very often people don't have the time to write all the test cases that they would want to write for the code base, or maybe the code base moves too quickly, so maintaining the test case is difficult. So you can use these robots to help you do that. Finally, it's a cool tool for continuous testing. You can put that into your Jenkins or whatever Travis and run the robot as frequently as you want. So I was saying before that we also have an API. Well, this is because when you run the robot in automatic exploration mode, well, it might start doing things that you're not interested about, right? That doesn't mean it's not interesting, but that might delay you for a little while, because you will have to wait until it gets to the place where you want to test your application. So we have an API that we call the conductor API that is there to control the robot, to direct it, and also to leverage automatic exploration. And that enables to test functional properties. Here's an example of how this API looks like. It's also a JavaScript API. So the first few lines are just to start the test session. So you load the URL and you say I want to do the automatic exploration. But then it's not because it's in automatic exploration that you cannot direct it. So you can actually write a few lines to tell it exactly what to do. So line 8 to 11, you can click, type, and click again. So this is an example where you do a sign-in. So if you need to provide a username and a password, you can do that very easily. You can see here the timing insensitive property of this API. So if you actually need to click on a menu before doing the next operation on your application, Bugbuster actually, since it's embedded deep into the browser, it actually figures out if there are AJAX requests or if there are timers and that kind of things, and it will wait in between two actions that you're queuing before it executes them. So you don't have to explicitly write code between a click and another click to prevent the robot from being too fast. Now that's for the sign-in, and then if you want to verify that you're actually logged in properly in your application, you can use a watcher. A watcher is basically an event emitter that spies on the state of your application and that triggers an event when something specific happens. So in this example is when some element shows up in the application. So that enables you to spy on your application, and then you want to encode the fact that this test session is going to be successful if you're properly logged in and unsuccessful otherwise. So for that, you can use a goal. So a goal is a promise that basically says, in this test session, the sign-in should work. If it's not explicitly fulfilled before the end of the test session, then you're going to have a bug reported. But if it is, like in this example, in this watcher, if we see the element signed in, then we know that we're logged in properly, so we can fulfill the goal and everybody's happy. That's an example of our API. In terms of technology, we're building all of that inside WebKit. So we have a heavily customized version of JavaScript core to do the instrumentation of the JavaScript and to figure out all these input values. We now have a beta version that is online, so I encourage you to sign up. It's completely free, and we'd like to get as much feedback from you guys as possible. That's why we're here today. And we're also considering porting our technology to V8 in order to provide the same technology for Node.js. So if you think that's interesting, let us know. That will definitely motivate us. So I'm getting near the end of my talk, and before I stop, I just wanted to clarify one thing. If you're doing test-driven development or behavior-driven development, if you're writing unit tests or Selenium test cases, by all means keep doing it. We're not saying that you should stop doing this. What we're trying to achieve here is to provide a way to test more, not less. So you can use these robots to basically try to cover as much of your code as possible and to complement whatever test cases you already have. But if you're writing, if you're using a development methodology that where you write your test cases, keep doing this. That's the best. That's the best thing that you can do. All right, that completes my talk. There are three of us here: Daniel and Renaud, and of course myself. So if you think this is interesting, if you'd like to see a demo, or if you just want to talk about technology, just come to us. Thanks a lot.